Today, we are diving into the next evolution of wireless technology, Wi-Fi 8. And here's the thing, it's not just about making things faster. It's about a revolutionary shift in thinking, making your Wi-Fi as rock-solid and reliable as plugging in a cable. Let's get into how.
We've all been there, right? You're paying for that blazing fast, multi-gigabit internet. Your router has all these antennas and promises incredible speeds, but your video call still freezes up or you get that dreaded lag spike right in the middle of a game. It's so frustrating. So what's the deal? Why is there this huge gap between the speed on the box and what we actually experience day to day? And this quote right here, it just nails it. For years, the whole Wi-Fi race was about one thing, hitting a higher top speed in a perfect lab environment. But you and I don't live in a lab. We live in the real world with walls and microwaves and a dozen neighbors all streaming at once. And in that world, raw speed means absolutely nothing if it's not stable. This realization, this is the entire philosophy behind Wi-Fi 8.
So the official kind of nerdy designation for the standard is IEEE 802.11bn, but its mission is right there in the name they gave it, Ultra High Reliability, or UHR. And this isn't just another small update, it's a massive philosophical change. The goal is to make your wireless connection feel just as stable, just as predictable, as if you literally plugged an Ethernet cable into your laptop.
So to really get this, here's our game plan. We'll start with a ridiculously powerful engine that Wi-Fi 7 built. Then, we'll see how Wi-Fi 8 adds a layer of intelligence with smarter signals and a truly coordinated network. We'll look at how this is going to kill those dead zones for good, all leading up to a future where wireless might just feel exactly like a wire.
All right, so to really appreciate just how revolutionary Wi-Fi 8 is, we first have to give credit where it's due. We have to look at the powerhouse that came right before it. Wi-Fi 7 was an absolute masterclass in pushing the raw limits of speed.
You know, the official project names really tell the entire story. Wi-Fi 7's goal was extremely high throughput, EHT. It was all about creating the fastest possible pipe for a single device. Wi-Fi 8 completely shifts the focus to ultra-high reliability, UHR. That's about guaranteeing great performance for every device across the whole network. Here's the best way to think about it. Wi-Fi 7 gave us a supercar engine. Wi-Fi 8 is giving us the smart air traffic control to manage it.
The absolute star of the show in Wi-Fi 7 was this thing called multi-link operation, or MLO. Think about it like this. If the 2.4, 5, and 6 gigahertz bands are all separate highways, MLO was the first technology that let your phone use lanes on all three highways at the exact same time. It was a massive, massive boost to potential speed. So yeah, Wi-Fi 7 gave us this incredible supercar engine, but what good is an engine if the roads are constantly gridlocked?
And that is exactly where Wi-Fi 8 comes in. It takes that monster engine from Wi-Fi 7 and starts building a much smarter road system around it. And this all starts at the most basic level, the physical signals themselves, what engineers call the Phi and Mach layers. Now this is super important. Wi-Fi 8 is not throwing away the insane speed gains from Wi-Fi 7. It keeps the super wide 320 megahertz channels and that really dense 4096 QAM modulation that packs in a ton of data. But instead of trying to push those numbers even higher, it focuses on making those existing speeds more stable and more usable in the messy real world.
Okay, so one of the really clever ways it does this is with something called unequal modulation. Imagine your router is sending out multiple streams of data to your laptop at once. Now, if one of those streams hits a patch of interference, older Wi-Fi would freak out and slow all the streams down to match the weakest one. With UEQM, the router is way smarter. It keeps sending data fast on the clear paths, but switches to a slower, more stable signal for just that one weaker path. It gets the most out of the total connection without letting one little hiccup ruin the whole thing.
This is another brilliant refinement. Think of how a car's transmission works. In older Wi-Fi, as your signal got weaker, your device would have to make these big, clunky downshifts in speed, like going from 5th gear straight down to 3rd. Wi-Fi 8 adds 4 new in-between gears, these new modulation and coding schemes. This lets your devices make tiny, smooth adjustments, which avoids those jarring performance drops. The result? A 5 to 30% better connection in the real world where conditions are always changing.
This focus on reliability is baked right into the DNA of the data packets themselves. You can think of a PPDU as the digital envelope that carries your data. Wi-Fi 8 introduces these new, more robust formats. But there's one that's brand new, the ELR, or Enhanced Long-Range Packet. And this one is designed to solve one of the most annoying problems of all, dead zones.
We'll see exactly how in just a minute.
All right, now we're getting to the single biggest, most game-changing idea in Wi-Fi 8. If Wi-Fi 7 gave us that powerful engine, this is the smart air traffic control system that finally lets us manage the entire network.
You know, up until now, even in a super expensive mesh network, every access point has basically been its own little island. They all politely listen and wait for the other islands to stop talking before they talk. They compete for airtime. Wi-Fi 8 completely flips that on its head by introducing multi-AP coordination. And fun fact, this was actually supposed to be in Wi-Fi 7, but it was so incredibly complex they had to push it. But now it's here. And it means multiple routers can finally act as one single intelligent system.
And this coordination happens in a bunch of really cool ways. With coordinated beamforming, all your access points can work together to aim their signals, making sure they don't blast over each other's conversations. With things like coordinated spatial reuse, they can actually figure out when it's safe for two of them to talk at the same time on the same channel. The big takeaway is this. We're moving from a system where routers just try to avoid each other to one where they're actively working together, collaborating to make everything more efficient.
So this new level of intelligence and coordination isn't just about getting better speed tests. It's about fixing the things that drive us crazy every single day. We're talking about network congestion, those annoying dead zones, and dropped connections when you just walk from one room to another.
Let's start with a classic one. The way Wi-Fi used to work, your whole giant 160 or 320 MHz channel was basically held hostage by one tiny little 20 MHz primary channel. If some old device was using that tiny primary channel, your brand new, powerful laptop couldn't send anything at all, even if the rest of that giant channel was completely empty. It was crazy. Non-primary channel access, or NPCA, finally fixes this. Your device can now see the primaries busy and just hop over to a clear lane to get its data through.
And the impact of this is huge. In crowded networks, just being able to use those channels that were sitting idle can boost your throughput by a staggering 37.5%. It's like opening a brand new lane on the highway during rush hour, just by being smarter with the space we already had.
Dynamic subband operation tackles a similar problem of, well, wasted space. Imagine your powerful new router is talking to an old smart home gadget that can only use a narrow channel. In the past, the router had to slow its whole operation down. With DSO, the router can carve out a tiny little slice for the old device and then use the rest of its giant bandwidth for your new TV, making sure no spectrum goes to waste.
Okay, so we've made the network way smarter, way more efficient. But what about when you get to the very edge of your house? You know, that one back bedroom where the Wi-Fi has always been terrible? Well, this is where that new data packet format we mentioned earlier becomes a hero.
The problem has a technical name, link budget asymmetry. But the idea is simple. Your powerful router can shout its signal all the way to your phone in the basement, no problem. But your little battery-powered phone can only whisper back. The router just can't hear it. This new Enhanced Long Range, or ELR packet, is designed specifically to make that whisper loud enough to be heard.
And how it does this is both simple and absolutely brilliant. First, it doesn't try to be fancy. It uses a narrow, stable channel with the most basic reliable signal types. Then, and this is the magic trick, it basically sends the same piece of information 4 times. That repetition creates a massive 6 decibel boost in signal strength, which is more than enough to turn that inaudible whisper into a clear voice the router can finally hear.
And you can literally see it right here in this signal analysis. This is a measurement of one of those ELR packets. Look how clean and stable that signal is, even in what would normally be a really tough, low-signal environment. This is what's going to make dead zones a thing of the past, at least for things like voice calls or your smart home sensors.
And finally, Wi-Fi 8 goes after the roaming problem. You know the drill. You're on a FaceTime call, you walk from the living room to the kitchen, and for a split second, everything freezes as your phone jumps from one mesh router to another. Seamless Roaming Domain, or SMD, fixes this. It basically makes all the routers in your house act like one single entity. So now your phone can just pass its connection smoothly from one to the next. It's a clean handoff, not a disconnect and reconnect. No more dropped calls.
So when you start to put all of these pieces together, the smarter signals, the coordinated network, all these features that eliminate the annoying dead ends, you really start to see the bigger picture, the grand vision of what Wi-Fi 8 is all about.
This table just lays out the journey perfectly. Wi-Fi 6 gave us more lanes on the highway for efficiency. Wi-Fi 7 dropped that monster MLO supercar engine in for pure speed. And now, Wi-Fi 8 is delivering the smart air traffic control, that multi-AP coordination, to make sure all that power is actually used well, preventing digital traffic jams and crashes.
And look, these aren't just empty buzzwords. The folks designing the standard have set really specific, measurable goals for ultra-high reliability. They are targeting a 25% improvement in speed in tough conditions, a 25% drop in worst-case latency, and 25% fewer dropped packets when you're roaming. These are real numbers for a real wire-like experience.
So if you remember anything from all of this, let it be this. Wi-Fi 7 gave us the high-speed engine. Wi-Fi 8 is providing the smart air traffic control. The whole mindset has shifted away from chasing theoretical top speeds to delivering guaranteed, consistent performance. And that is what will finally unlock wireless for truly mission-critical stuff, from robots in a factory to genuinely immersive AR and VR.
And that really leaves you with a final thought to chew on. For decades, the most demanding things we do have always needed a physical cable. When wireless finally becomes just as dependable as plugging in, what new possibilities does that open up? What can we build, what can we create, and what can we experience when the network itself is no longer the thing holding us back?
And that is a look at the future with Wi-Fi 8. If you enjoy getting to the bottom of the key technologies that are shaping our world, make sure you subscribe to the channel. Thanks for watching.